Have you ever looked up at the night sky, filled with countless stars, and wondered, how did all of this begin? It's one of the oldest and biggest questions humanity has ever asked. Today, we're going on an epic journey, back in time, all the way to the very beginning, to unravel the complete story of the creation of our world. Our story starts with a bang, not just any bang, but the Big Bang. Imagine a point infinitesimally small, yet containing all the energy and matter of the entire universe. About 13.8 billion years ago, this single point exploded in the most cataclysmic event imaginable. This wasn't an explosion in space, but an explosion of space itself. In a fraction of a second, the universe expanded faster than the speed of light, a process scientists call inflation. From a size smaller than an atom, it ballooned to an astronomical scale. In these first fiery moments, the universe was an incredibly hot, dense soup of fundamental particles. It was too hot for anything we recognize today to form, not even atoms. Quarks and gluons swirled in a chaotic plasma, but as the universe expanded, it also cooled. Within the first few minutes, things started to settle down. Protons and neutrons came together to form the first atomic nuclei, mostly hydrogen and helium, the building blocks of everything that would come later. For the next 380,000 years, the universe was still a foggy, opaque place. Light particles, photons, were constantly scattering off free-flying electrons, unable to travel far. But as the universe continued to cool, a magical thing happened. Electrons were captured by the atomic nuclei, forming the first stable atoms. Suddenly, the fog cleared. The universe became transparent, and light could travel freely for the first time. This first light is something we can still detect today, a faint cosmic echo known as the cosmic microwave background radiation. It's like a baby picture of the universe. After the lights came on, the universe entered what we call the cosmic dark ages. There were no stars, no galaxies, just vast clouds of hydrogen and helium gas drifting through the expanding darkness. But this period wasn't empty of action. Gravity, the silent architect of the cosmos, was patiently at work. Tiny, almost imperceptible variations in the density of the gas clouds meant some areas were slightly more massive than others. These denser regions started pulling in more and more material. Over hundreds of millions of years, these gas clouds collapsed under their own gravity, growing hotter and denser at their cores. Eventually, the pressure and temperature became so intense that nuclear fusion ignited. Boom! The first stars were born, lighting up the cosmos and ending the dark ages. These first-generation stars were giants, hundreds of times more massive than our own sun. They burned incredibly hot and lived fast, spectacular lives, lasting only a few million years. When these massive stars died, they went out with a bang, a supernova explosion. These explosions were crucial for our existence. Inside their fiery cores, these stars had forged heavier elements, like carbon, oxygen, and iron, from the simple hydrogen and helium. The supernova scattered these new elements across space, enriching the cosmic clouds with the raw materials needed for life. It's no exaggeration to say that we are all made of stardust. These enriched clouds of gas and dust then became the nurseries for the next generation of stars and planets. Gravity continued its work, pulling this material into spinning disks. At the center of one such disk, about 4.6 billion years ago, the pressure and heat once again ignited nuclear fusion, and our star, the sun, was born. Around the newborn sun, the rest of the disk flattened out into a swirling protoplanetary disk. Dust grains began sticking together, a process called accretion. Clumps grew into pebbles, pebbles into rocks, rocks into planetesimals, and planetesimals into protoplanets. It was a chaotic and violent process, with constant collisions and mergers. Out of this cosmic construction zone, the planets of our solar system began to take shape. In the inner, hotter regions, rocky planets like Mercury, Venus, Earth, and Mars formed. In the outer, colder regions, gas giants like Jupiter and Saturn, and ice giants like Uranus and Neptune gathered up huge amounts of gas and ice. Our own planet, Earth, had a particularly dramatic start. In its early days, a Mars-sized protoplanet, which we called Theia, smashed into the young Earth. The collision was catastrophic, melting both bodies and throwing a massive amount of debris into orbit. This debris eventually coalesced under gravity to form our companion in the cosmos, the Moon. This giant impact also tilted Earth on its axis, giving us the seasons that make our planet's climate so dynamic. For the first few 100 million years, Earth was a molten hellscape, constantly bombarded by asteroids and comets. Left over from the solar system's formation, this period is appropriately called the Hadean. But this constant bombardment had a silver lining. The comets and asteroids, which are essentially dirty snowballs, delivered a crucial ingredient to our planet: water. Over time, as Earth cooled, this water vapor condensed and rained down for centuries, filling the basins and forming the first oceans. The stage was now set. We had a rocky planet, at just the right distance from its star for liquid water to exist, with a protective atmosphere and a large moon to stabilize its rotation, but the planet was still sterile. The final, and perhaps most mysterious, step in our creation story was about to unfold. The origin of life. Around 4 billion years ago, in the warm, chemical-rich waters of the early oceans, something incredible happened. Simple organic molecules, perhaps delivered by comets or created in deep-sea hydrothermal vents, started to self-assemble. They formed complex structures that could replicate themselves. The first life on Earth had emerged. These first life forms were simple, single-celled organisms. For billions of years, they were the only inhabitants of our planet, but they were busy. Through a process called photosynthesis, some of these early microbes started producing oxygen as a waste product. Slowly, painstakingly, they transformed Earth's atmosphere, filling it with the oxygen that more complex life would need to breathe. This great oxidation event paved the way for the next great leap, the evolution of multicellular life, about 600 million years ago, in an event known as the Cambrian Explosion. Life on Earth diversified at an incredible rate. The oceans teemed with strange and wonderful creatures, the ancestors of almost all animal life today. From the oceans, life eventually conquered the land. Plants first, then insects, then amphibians, reptiles, and finally, mammals. The planet saw the rise and fall of the dinosaurs, massive volcanic eruptions, and dramatic ice ages. Through it all, life proved to be resilient, constantly adapting and evolving. And then, in a very recent chapter of this cosmic story, on a small branch of the mammalian tree, a species emerged with a unique ability. The ability to look up at the stars, to question its own origins, and to piece together this entire incredible journey. That species is us. From a single point of infinite density, to the birth of stars and galaxies, from the formation of a small rocky planet to the first spark of life, the creation of our world is a story of cosmic proportions. It's a story written in the stars, in the rocks beneath our feet, and in our very DNA. It's a testament to the power of gravity, chemistry, and time. So the next time you look at the night sky, remember this epic 13.8 billion year saga. You're not just looking at distant points of light, you're looking at the history of the universe and the story of how we came to be. It's a story we're still uncovering, and the more we learn, the more awe-inspiring it becomes. Thanks for joining me on this incredible journey through time. If you enjoyed this cosmic story, don't forget to like, subscribe, and hit that notification bell for more deep dives into the wonders of our universe. Until next time, keep looking up.